Hello, everyone. So, last time in class, we discussed the z-score, which remember is the value minus the mean and then divided by the standard deviation. And that's a way of finding how far any certain number is away from the mean. And today we're going to talk about transforming data. So the z-score is just transformed data. We can analyze the effects of transformations on a distribution. Transformations occur when you add, subtract, multiply, or divide all values by a number. These are your notes for today. You can download them in the day 3 folder and just follow along as I walk you through this. So when we think about transformations, you can think of this the same way that you might have learned it in algebra class if you did that, where if we have any graph and we add or subtract to it, that keeps it the same shape and it just moves to the left or right or up and down. It's the same way with statistics. When we add or subtract, all it does is take our curve, our data distribution, and move it. It doesn't change the shape and it doesn't change the spread. The one thing that it does change is the center. So we can imagine this, something like this. If we have a skewed distribution like this, and we say, okay, we're going to take every value in this distribution and add 10 to it, then every single value is going to move up a little bit, but it's going to be the same shape. That's what adding and subtracting does. But if we multiply or divide, the shape will stay the same. So it will still be the same shape, but the center, spread, and location will change. So if we have something like this that's pretty compact and we decide to multiply it by 3, let's say, the whole thing is going to move and it's going to be more spread out. So we'll see a lot more changes with that. Now, here's an example. We're looking at test scores. When we look at this sample, we can see that the mean of the data is 35.8 and the median is 37. Those are our measures of center. Then our measures of spread would be the IQR and the range. So if we look at this first part A, suppose the teacher was nice and added 5 points to each test score above. How would this change the shape, center, and spread of the distribution? This is adding, which means that the only thing that will change is the center. The shape stays the same, so it will look just like that dot plot, and the spread stays the same. Nothing gets stretched out, which means that shape and spread stay the same. Mean and median will increase by 5 because the teacher added 5 points. Suppose that the teacher wanted to convert the original test to percents. Since the test was out of 50 points, how would this change the shape, center, and spread of the distribution? This one takes a little bit more thought. What does it mean to say that the teacher wants to convert the test score to percentages? Well, percents are divided by 100, right? They're out of 100. So if we had a test that was worth 50 points and we want to write it as percents, we're going to have to multiply times 2 because 50 times 2 equals 100. So we're going to take every single point here and multiply it by 2, which means that all of them are going to move, right? So that our center and our spread will change, but the shape will still stay the same. It's not going to change from like it is now, where it's a little bit left skewed. It's not going to change to right skewed. So we multiply all of our values by 2. Our new IQR will be 18. Our new range is 72. New mean is 71.6. And our new median is 74. This last part we're going to go over as a class, but we're looking at this last part. When combining transformations, write an equation to illustrate what's happening and solve the equation for the other variable, then apply the transformations. This is the problem that we're coming to. I haven't filled it in for you, but we're going to look at this in more detail, thinking about what's happening to this transformation. So that's all I want you to consider right now. If we are thinking about the miles as one distribution, then what do we have to do to that miles to change it into the fare? Well, we're taking the miles and we're multiplying everything here by 2. And we're also adding 2.5. So we're going to transform this distribution in 2 different ways. And we'll think as a class about how that might look. You can continue reading this. The next part is about density curves, which we've kind of seen before. We've seen histograms like this. Density curves is just the drawing of it over top. And we'll go into this in more detail. But the main point of this is that the density curves show us the smoothest way to look at it. And they can be a lot of different shapes, right? So we can have a density curve that's skewed to one side, like this one that's right skewed. And we're going to try to find the balance point to divide it into 2 equal areas. The median is always going to be the point at which the whole curve balances. So we can imagine that it's on a scale or on a teeter-totter. And we're going to have to line up with the median. If we line up with the mean, it would be a little bit wonky. So if the distribution is symmetric, we've talked about this before, the mean and median will be the same. If the distribution is skewed, the mean will be pulled towards the skewness. All right, that's it for today. Read through these notes and come to class with a question or comment about what you learned from this notes.